Made it. Okay, thank you. Okay, hi. My name is Elana, from a company called Mobileye. And I work as a safety architect to define, design features for safety critical systems, mainly in the automotive domain, Linux-based. We started this group, I think it came from a little bit of a different angle than other groups in ELISA. And I copied here what started out as our original statement. The goal was to bring together people who are not coming so much from the safety community, but people who work as system architects, developers of systems, safety critical systems, who understand and use different kernel features, and to investigate how those kernel features can be used, can be enhanced, can be improved, can be developed even long-term, so that we can create systems which are relevant for use in safety critical systems. And the point of this working group was not to make any safety claims, not on Linux, not on those features, but on this, but from understanding the pain points or what is needed, different features which are relevant for use in safety critical systems, to provide, which is what Linux does, to provide code features as is, and leaving it up to the integrator to define their own safety requirements, their own context for the use of those features, and to prove how and why they support their safety claims. But there are certain basic mechanisms which we feel and we understand, and from what I see in designing practical systems, are fundamental to the development of safety critical systems. So that, for example, on the right, these are all taken straight, copied as is from the mission statement of the group. For example, memory protection is something which is very fundamental. So one of the goals is to understand memory protection features which are available in Linux or can be available in Linux, how they work, the interaction between hardware and software, how we can test systems, and what kind of evidence those different tests, complex software embedded in embedded systems, multi-threaded systems, how we test such systems, and what the different type of test utilities which Linux provides, what type of evidences they provide for us, et cetera, different features. There's a whole subsystem based on advanced error reporting for fault handling. We do not, again, make any claims that their use is safe as is. It's not a plug and play issue, but there are different types of features which we feel can be judiciously used by the designers and the practical users of Linux to design safety critical systems, and therefore we want to raise awareness of those features, and perhaps with time to gain contributions which are which have safety in mind, so that Linux can provide features which designers of safety systems can use more readily as a basis for their safety claims. Okay, so the emphasis on this work group is more on, as you know, I put bold text on the left, that's not in the original charter, obviously, to bring together those kernel developers and producers, and this, I guess, this presentation is an open invitation for anybody who thinks they can contribute and are interested in any of these areas. What we've been working on mostly in 2023 is on RT Linux. Okay, and if you go to our Git, maybe I'll add after this a slide with some links and pointers. But we have a GitHub site, and it whatever. There's a lot of other additional material from the past. But in 2023, we've been working on understanding how we use RT Linux in safety critical systems, basically trying to bridge that gap of using RT Linux and what type of safety claims you can make on the use of RT Linux and how it can be properly used, and not having to resort in certain use cases to the use of a proprietary RTOS. There's work in progress on the documentation, and I'm not going to go into the details of the document. If anybody is interested, they can take a look, and we can follow up afterwards, via email or otherwise, or joining the working group sessions. We have integration guidelines we give for how you can integrate RT Linux into safety critical systems, different considerations for kernel configurations to support system safety, and proposals for enhancements and features, while obviously trying to capture some of the challenges and some of the pain points which need to be dealt with. And my experience comes from real usage in Mobileye products. Okay, the areas of my contribution come directly from my work, from systems which I design and develop, and I continue to look for that kind of collaboration with business entities for which maybe there will be a win-win type of two-way contribution and gain. Okay, some of our work was presented at the Safety Critical Software Summit in June in Prague. I spoke about, what I mentioned before, different features, different configurations. Shua Khan, I think she's not here now, but she's from the Linux Foundation. She did some experiments on different tools and testing and demonstrations of RT Linux usage. And we did discuss afterwards some ways of following up and continuing that work. Okay, the document itself, like I said, it's a dense, well over 20 pages of content, and I'm not going to go into the details in this short overview because there's a lot of technical details there. Okay, what's coming up? We are looking for partners and collaborations, perhaps for business partners who want to work together. Again, different areas of interest, mostly emphasizing, the system architecture and how safety fits in there. I call this bullet facing reality, but in a sense, understanding that Linux is here to stay. It's being used in safety critical systems more and more. And the question is, how do we leverage the power, the openness of Linux to be able to publicize, collaborate, and contribute together to create a better infrastructure of features which may be used. And I'll finish just with this quote, which is directly taken from the Linux Charter. And this is what we aim to do in this group, to define a set of elements. And we see that as actual, elements of code, Linux features, which are amenable to safety certification, meaning we don't make the safety claims themselves, but they are intended to support features which, if used properly and aligned with the safety standards and the requirements of the safety requirements of any specific use case can be helpful in supporting safety certification, something that we have found is certainly possible with the rich repertoire of Linux features which currently exist and are continuously growing. So that's basically all I have to say. If anybody has questions, and if anybody's interested in joining, following up, raising additional topics, contributing to that document and as a work in progress. Anything else?
Yes, thanks a lot, Elana. So
What?
you typically meet on Tuesdays, I guess, and a good way to start is most likely dropping a mail on the mailing list. What I think.
Yeah, I'll add a slide at the end with the different links, okay? Before I
Perfect.
share
Yes.
this. I know, I didn't get to doing that yet, so
Yeah. So this will be the entry point for us.
yeah.
Hey. Oh yeah, Paul was asking where we can see the current work in progress document on RT Linux. I think you have some work
Okay,
in progress on the
it's
GitHub, right?
that I put the link in. Here it is here, you see? So that's the link to the document, and this is the link. It's not only saying that it exists, it's a link to the actual documents in Google Docs. And I will add the final slide with a link to the GitHub, and you can see there are links to other works that have been done there.
Cool. So ask question, you can post it to the chat.
To post it in the chat. I look here. Can I find it like this? How do I see it? Oops, now I see it in another screen, but I'll copy it to the chat. Okay.
Thank you so much.
Looks encrypted. Okay. Oops, I'm sorry. I put it to